Inductive effect is an important electronic effect where the electron density plays an important role in case of single bond. So inductive effect will be seen in compound where we have a single bond. Previously we have discussed about electromagnetic effect where it was seen. I'm writing electromagnetic effect as EE, and this is seen in compounds having double bond or multiple bonds. So when we are talking about single bond, it means sigma bond. So when we are trying to polarize in the sense when we are trying to induce positive and negative charge in the atoms attached to each other with the help of a single bond, that is sigma bond. So we are representing here that inductive effect is going to polarize, that means positive or negative charge on the sigma bond due to the presence of electron withdrawing or electron donating effect of adjacent group of adjacent group. Adjacent group is it is due to the atom present next to the carbon chain. For example, if you're talking about 1, 2, 3, 4 carbons, and when it is attached to a Cl here, you need to remember here one thing very clearly, that the atoms which are attached here is 1, 2, 3, 4 carbons, and this one is a chlorine. Chlorine is supposed to be more electronegative, and due to the difference in electronegativity, the sigma bond which is present between this carbon and Cl get polarized. That means because of the electronegativity value higher for chlorine, the sigma electrons from the adjacent carbon move towards chlorine, and this leads to generation of a partially negative charge on chlorine. So due to difference in the electronegativity of carbon and chlorine, chlorine is more electronegative. That means it will have tendency to accept more electrons. From where can they get electron? From the bond which is forming sigma bond. So sigma electrons will be pulled towards the chlorine, and this results in the formation of partially negative charge on chlorine and partially positive charge on this particular carbon. And this effect is moving to the chain. The next carbon is also trying to contribute electrons, and this will get partially positive. Then this will also be compelled to donate electrons, and this will be partially positive. So inductive effect is a permanent effect. Inductive effect is actually transmitted through the sigma bond along the chain. The magnitude or the power of inductive effect is decreasing when it is trying to move away from the electron withdrawing group. The electron withdrawing group here is Cl. Withdraw means it is pulling the electrons. So the effect is more on the carbon number 1, then followed by carbon number 2, then followed by carbon number 3, and the effect is diminishing when it is moving towards the fourth carbon. So the basic thing what you need to remember is inductive effect is polarization of which bond? Sigma bond, due to the presence of electron withdrawing or electron donating effect of adjacent group. This is the basic definition. And you need to remember a few important points in this inductive effect is it arises due to difference in electronegativity. second point important is it is transmitted through the sigma bond. As we have seen here, all are sigma bonds here. This one is sigma, this one is sigma, this one is sigma. So it is transmitted means it is moving, or it is actually showing its effect through the help of sigma bond. The magnitude of inductive effect decreases while moving away from the group. As we have seen, this is partial, then this is partially positive, this is partially positive. That means the value of positive charge is decreasing when it is moving away from the electronegative chlorine atom, and this chlorine atom is electron withdrawing in nature. It is electron withdrawing in nature. That means they try to pull electrons towards it, and it is a permanent effect. Electromeric effect was temporary effect. It influenced the chemical and physical property of the compound. Physical properties and chemical properties are affected. The inductive effect refers to polarity produced in a molecule as a result of higher electronegativity of one atom compound to the another. That means when you're trying to compare carbon and chlorine, carbon is less electronegative than chlorine, and because of electron withdrawing nature, more electrons are drawn towards chlorine. This results in the formation of partially negative charge on chlorine and following the partially positive charge on carbon. So in the above statement which I have said, inductive effect refers to polarity. Polarity means negative and positive charge is produced as a result of high electronegativity of one atom. In this two atom, chlorine is supposed to be having high electronegativity, and because of this high electronegativity or different electronegativity, polarity is induced along the sigma bond. And this inductive effect does not depend on any reagent, whereas inductive electromeric effect is dependent on the presence of an reagent. The other points which we have already discussed is here in our illustration of inductive effect. The points mentioned are same. The sigma bond which form covalent bond are rarely shared equally between the two atoms. This is due to difference in the electronegativity value of two atoms. So there is difference in the electronegativity value, and this leads to inducing of this polarity on the sigma bond. Consequently, electrons are displaced towards more electronegative atom. We have seen the example of butyl chloride. I'll write butyl chloride in total. So for example, 1, 2, 3, 4 and a Cl. Here it will be CH2, 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 and this one is CH3. This is electron withdrawing group, and this is having higher electron negativity. So this is going to cause electron pull from the first carbon attached, and this results in the formation of partially negative charge, partially positive charge. This carbon now here will pull this carbon, will ask for more electrons, so this will try to donate, so it will give partially positive. Then this carbon will ask this carbon to donate few more electrons along the sigma bond, so it will go and give it to the next carbon. It will be partially positive. Actually, the bond should be attached to the carbons. I'm showing it in a away form. So what happens here is the electrons are displaced towards the more electronegative atom. Displacement, it is moving towards more electronegative atom. Here more electronegative atom is this chlorine. And what is the representation here? Is the first carbon atom gets partially positive charge, which we have shown here. In turn, the carbon atom drags the electron density partially from the next carbon, as we have shown here. This one, the second carbon. It drags the electron from the next adjacent carbon, which also gets partially positive charge. Thus, inductive effect is transmitted along the carbon chain. It is transmitted from here till here. Inductive effect weakens away along the chain and is not sufficient beyond the third carbon. So this one is first carbon, second carbon, third carbon. So inductive effect is seen till the third carbon. The fourth carbon will not show inductive effect as shown by third, second and the first carbon. The next point here is inductive effect weakens away along the chain and is not significant beyond the third carbon, which we have discussed. And one more example here is for carbon and hydrogen, the electronegative values are almost same. So there is no pulling of electrons from carbon to hydrogen, or there is no pulling of electron from hydrogen to carbon. So there is no inductive effect shown. The value of inductive effect is actually 0. So this is taken as an example where there is a 0 effect. There are two types of inductive effect, plus I and minus I. Minus I inductive effect is due to the presence of electron withdrawing group. Plus I inductive effect is due to electron donating group. Electron withdrawing nature of group is called as negative inductive effect. Atoms or group which draw electrons away from the carbon atom are said to have negative inductive effect. Examples are chlorine, fluorine, bromine, iodine, OH hydroxy group, C6H5 group, COOH group, CHO group, ketone, CN cyanide, NO2. These are the few examples of the atoms which show negative inductive effect. So this one is showing negative inductive effect example. Positive inductive effect is shown by electron releasing compounds. Here we are having the example of CH3 taken thrice bonded to carbon, or CH3 taken twice bonded to CH, or CH3 CH2 or CH3. Basically all are representing alkyl group. So these alkyl groups show positive inductive effect. See, very simple concepts are involved in inductive effect. Inductive effect is a permanent effect. It is only in single bond, that means sigma bond. Polarization is due to the difference in the electronegativity value. We have seen few examples which we have represented here with butyl chloride. We have seen once again example here, and the important point to remember here is it doesn't require any reagent. We have seen here example of butyl chloride thoroughly, and we have also observed that inductive effect is limited till third carbon, and the effect is not significant after the third carbon. After this particular representation, where we have seen of plus I and minus I, plus I is positive inductive effect, minus I is negative inductive effect. We're going to see a few application of inductive effect where, for example, we have a compound which has positive charge and has CH3 and CH3. This carbon has 3 bonds and a positive charge. It is called as carbocation and also called as carbonium ion. So when you have 3 carbonium ion, here it is tertiary carbonium ion, followed by carbon having 2 CH3s attached. Here it is hydrogen with a positive charge. This is secondary, followed by carbon having only 1 CH3 and 2 hydrogens and a positive charge. Still it has all the carbon has 3 bonds and positive charge. This one is primary, and the final one is carbon with all 3 hydrogens. This one is methyl group or methyl carbonium ion. So when you have a compound where we have carbonium ion means positive charge, that means it is electron deficient, it has less electrons. The positive sign here denotes that it has less electrons, and the CH3, as we have seen here in plus I effect, are electron donating groups, so they donate electrons. So When you need electrons, that is shown by a positive charge, and when you have more donating groups, then the compound is supposed to be more stable. So when you have three donating groups, and this is tertiary carbonyl ion, so this compound is supposed to be more stable, followed by secondary carbonyl ion where we have two donating groups, followed by primary carbonyl ion where it has one donating group, and here they don't have any. In methyl, no donating groups are present. So when there is these kind of compound present, so this concept of inductive effect helps us in deciding out of this option which is supposed to be more stable. Now we have understood that CH3 groups are electron donating group and it shows plus I effect. So that is why it is making your tertiary carbonium ion more stable, followed by secondary, followed by primary, and finally methyl carbonium ion. Same way we have another application where stability of free radicals is predicted. Free radical is a compound having single electron present on it. That means it requires more electrons, and if we have more donating group present, that is CH3, 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 three donating group present. So this is more stable, followed by 2 CH3, this is secondary, this is tertiary, followed by carbon having 1 CH3, and rest are hydrogens. It is primary, followed by C, H, H, H. It is methyl free radical. So this is tertiary free radical. This is methyl free radical. Here we don't have any electron donating group present, so this is least stable. We have one electron donating group. This is more stable than methyl. This we have two electron donating group. This is stable than primary, and this is having three donating groups. Then it is making this tertiary more stable. So this is what are the application of inductive effect in deciding the stability of few compounds. There are many more applications. Right now for your semester examination, I think this two will be sufficient. I suggest you all to kindly refer to the syllabus copy of your semesters. That is 1-2 for the subject of organic chemistry, where the fourth chapter deals with carbonyl compound, and this inductive effect is not present in the fourth chapter. It is actually a part of fifth chapter, but I am discussing it here as I have already completed electromagnetic effect, which is listed in the fourth chapter. The fifth chapter actually talks about inductive effect, but because of the continuity issue, I have discussed this problem so that it will be easy for you to understand inductive effect immediately after electromagnetic effect. In this fourth chapter, the topics remaining are qualitative test. I hope that you people will go through few notes which you already have studied in your intermediate levels, where this topic is more thoroughly discussed. So kindly refer to those books where qualitative tests for carbonyl compounds are there, with Tollin test, Fehling test, other name tests are there to distinguish between aldehyde and ketone. The next important thing here in this particular chapter is structure and uses of few carbonyl compounds, where I suggest you to go for at least 5 uses for the compounds. You can search in various textbooks, or you can just Google it out and make a note of it. I hope you guys can cope up with the uses part. And the structural part, I'll tell you which are more simpler ones first, and the complex one I'll tell you at the end. The simpler part is actually where we have already seen what is formaldehyde, is compound where we have H, C double bond OH is formaldehyde. The next compound after formaldehyde is acetone, CH3, C double bond O, CH3 is the structure of acetone. After acetone, chloral hydrate is carbon having OH and CCl3, if I'm not wrong. This is chloral hydrate. Next compound is hexamine and paraldehyde. I'll discuss later. The structural part. These one are easier one. I will suggest you to just go through the structures and uses part. Each compound at least 5. If you can remember more, it's well and good. But at least 5 uses should be properly uh, written in your examination, and I hope that you guys will refer to the notes or the text which are available in online. After chloral hydride, the next compound is benzaldehyde, where we have a benzene structure of phenyl CH5 with C double bond OH as a benzaldehyde. We can also write it as C6H5C double bond OH. Vanillin is another extension for benzaldehyde, the same structure. C double bond OH. Here you have ester part, that is CH3O, and here OH, which makes it as also a phenol. So this is vanillin. The last compound in this is cinnamaldehyde, where you have CH5 CH double bond CH C double bond OH. The only part extension is this one when you compare with benzaldehyde. So this is cinnamaldehyde. So these are the few structural part which we have discussed now, along with inductive effect. I suggest you all to just go through the topics thoroughly and make use of the structural part which we have discussed. This is formaldehyde, acetone, chloral hydrate, benzaldehyde, vanillin, and cinnamaldehyde. Remaining two structures. The only two things which you have to cover in this chapter is qualitative test and the uses part of the structure. The rest we'll discuss in our next class. I believe if the fourth chapter is finished, we'll start up with the fifth chapter, which is very simpler one and very small one. I think we can complete this in 1 or 2 days, followed by the third chapter. So please make use of the time which you have and practice all the structural part and the reaction part which we have discussed, referring to the video and notes, and you can also refer to the other textbooks which are available with you. Thank you very much.